Okay, before we talk about ground fault protection, guys, I want you to go, um, let's go to the code book before we even talk about the topic of ground fault protection and say a few things about, highlight a few things in the code where the requirement for ground fault protection for dwelling. Ground fault protection for dwelling, highlight them in the code if you guys have not done that before. And then we can go to directly to our building. Small appliances, 210.dwelling. Okay. Image 52. Okay. Computers. All right, so let's see if we can go here. We're gonna go over chapter 6, guys. If you can go directly to chapter 6 and a few applications. Right. Okay. 10. 210. Okay, 210.8. Let's go quick to 210.8, guys, and just highlight these if you have not done that, please. Let's go directly to 210.8 all the way. 210.5, 210.8. Okay, great. Take this one in. So if you guys have not highlighted this in GFCI requirement, this one of the most important articles that you probably will be looking at. And I'm going to highlight it, and then we'll go into details, a little bit more details. Okay, so if you look at this article, 210.8 ground fault protection in dwellings, it lists in the dwellings where all the circuit breaker or all the ground fault protection that you need, guys. And we're going to list them quick here. And because I want to highlight them, I should have started my smart board first. This Chad. Okay. It's easier to. Okay. So we're in. Go here. Okay. Dwelling units. If you guys please highlight this article if you have not done that. All these locations, they have to have a ground fault circuit protection in the dwelling. Since we're residential, the rest of them will be adjusting it as we go. The most convenient voltage, the most convenient amps, the 15 and the 20 and the 120 have to be GFCI protected in the following location. All bathrooms, garages, and also accessory floor located below grade, so that will anything below grade, storage areas, work areas, and similar areas. These are very interesting places. Any damp wet location have to have a GFCI protection. Outdoor, all your receptacles outdoor have to have a GFCI, crawl space, unfinished basement. So these are the main location that you need a ground fault circuit protection for in residential, in dwelling. And I want to highlight the word in dwelling units. Any question, guys, about that? Any question about the location that you need a ground fault circuit protection there? There's an exception. I want you guys to highlight this exception here. I don't know how many of you have seen it. Receptacles that are not readily accessible and are supplied by a branch circuit dedicated to the electric. That's electric snow melting, de-icing, or pipeline and vessel, blah, blah, blah. Equipment shall be permitted to be installed in an in according to this. So if you have a circuit, that you feed from that circuit, outdoor circuit, and you have an equipment that de-icing and snow melting equipment, doesn't have to be in a GFCI receptacle. But what they do is, guys, if you go to 426.28, they put them on a ground fault protection equipment. Ground fault protection, which is less sensitive than the ground fault circuit interrupter. So any question, guys, about this? Any question about the dwelling? Where do you need them? Long story short, GFCI are needed in every place there is water. If you look at all the common denominator between all these places is wet or damp, and have some water in it. So if you go a little bit down here, there's a couple of other locations. So we talked about the outdoor pulse base, unfinished basement. We have also in the kitchen, countertop, all the countertop, anything within 6 feet of a sink, excluding the sink, bath, boat houses, if you have one. So all these locations need a ground fault circuit protection. I want to highlight this exception here. I don't know how many of you guys have seen. If you have a receptacle in your basement dedicated for the security system, one receptacle dedicated for your security system, then you don't need GFCI protection for it. Any question, guys, about the location of the GFCI protection?
Regarding the clause about readily accessible, it's kind of one of the questions in the homework. Says you put in a freezer. Typically, you put an outlet with the freezer.
Thank you. In 2000,
the outlet, it's no longer accessible.
In 2011, that's only in 2011, they start requiring all these locations of GFCI to be readily accessible. Before that, not a big deal. Readily accessible means you can't climb or push or pull something. So if you have a freezer and you want to put the freezer, have to be in a GFCI in an unfinished basement or garage. So you have to put the receptacle right next to the freezer, not directly behind it.
You can't control that.
Right, because the homeowner is going to freeze.
You can only install things, and yeah, I see your point. How are you going to control the behavior of the people? But you can sometimes, yeah. How are you going to control the behavior of the people? That's the challenge. Is how are you going to control the behavior of the people? But you are not.
It makes sense to cover the receptacle with the freezer so somebody doesn't unplug it, or.
But the whole idea, if it trips, they need readily accessible people. You know, it's not convenient for people if it trips to reset it.
Right. I mean, the potential would be you don't put a GFCI outlet there because it isn't accessible.
That's a good point. And why should you put a GFCI receptacle when it's not accessible? Unfortunately, you have to have a GFCI receptacle now, and you have to be accessible. So that to the best of your ability, guys, when you put your receptacle, they have to be in a location that's accessible. And you can argue, I put it right here, Chad, and the owner went and put the freezer right in front of it. So, but all these in 2011, they added all these locations, guys, must be readily accessible. Meaning, if you knowingly know that the only place, for example, you have just a tiny little slot here for your freezer, and you put a receptacle right here for the freezer, knowing that there will be a freezer here thrown right in front of it, you might have to put your freezer, your circuit breaker a little bit higher than the freezer. If you know, if you don't know, you can't control, as we said, people's behavior. Any question, guys, about the location? And they have to be readily accessible. Location and readily accessible. So I'm not going to talk about non-dwelling. In non-dwelling, almost bathroom, kitchen, rooftop, outdoor units, the same thing, sinks and so forth. We'll talk about this one in non-dwelling when we go to the commercial. But in a dwelling, basically, you can count in any wet or damp location. You almost have to have a GFCI unit. Any question about the location of GFCIs? Before I quick, and please highlight this one. We'll get back to it when we go commercial. So here's bathrooms, kitchens, rooftop units, outdoors. And if you go down, there's sinks. These are non-residential. So if you go a little bit down, it will take you down to the sinks too. There's some exception. I'm not going to go talk about the exceptions. There's sinks and boat hoists and so forth. These need a ground fault circuit protection. Any question about the ground fault circuit protection location based on the code highlighted?
I just got a question about
Yeah.
freezers. I know I probably brought this up last week, but here's a situation that happened in my house. We've got a garage and we've got a freezer out there.
Okay.
And we've got it, plugged into a GFCI circuit, the garage circuit. And we had a party going on, so we had what do you call them? Slow cookers or crock pots going.
Yeah.
And we eventually, broke the circuit, and then the freezer was turning out too. So, what's your suggestion for freezers and design for freezers?
Through a brand circuit for it.
Just a separate circuit.
Yeah.
Okay.
It's in a where is that in a
In a garage.
in a
Not-
garage?
Not a
Yeah.
basement.
Yeah.
I mean,
If that freezer was on a dedicated circuit by itself, it wouldn't trip because it doesn't. It tripped because you overloaded the circuit. Most likely, it tripped that. Which trip? The circuit breaker or the GFCI?
The circuit breaker.
Circuit breaker. So you overloaded the circuit. It's just too much stuff on it. Yeah, that would be a good idea to put it on a dedicated circuit.
Right, because if you got a guy tooling around in his garage with a bunch of tools, motors and everything.
You can easily exceed that one. Absolutely. Okay, one more thing, guys, before any question about the GFCI locations, before I move on to the arc flow circuit interrupter. The other thing I want to highlight here, if you do me a favor, if you have not highlighted this, please go all the way to 210.12. 210.12, it tells you the location where you need arc flow circuit interrupter. Let's highlight this one so we can get them once and for good. This is the location where you need an arc flow circuit interrupter by code. The same thing, Chris, the most convenient amps and the most convenient voltage, 120 and 50 and 20 amps. The location that you guys need to install in the dwelling unit family room, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreational rooms, closets, hallways, similar rooms, areas, shall be protected by a listed arc flow circuit interrupter combination type installed to provide protection. Any question about these? So this is where it tells you where you need an arc flow circuit. Basically, if you look at these areas, you need them in every location that there is no GFCI. FYI about this requirement, guys, right here, this applies to lights as well as receptacles. Lights and receptacles. Any question?
This combination type, so that's the type that has both GFCI.
No, combination type in this case, but when I got it mistaken a couple of times here. When they created the arc flow circuit interrupter, guys, it used to look at the parallel arc, the arc between a phase and a neutral, or a phase and a ground. The electronic will look at only a parallel arc between hot and a neutral, hot and a ground. But what happens if you break the hot, the series? So what happens if you break the hot? There will be an arc between this side of the hot and the other side of the hot. Not completely break it, but not good connection. So they created that combination type which looks at series and parallel arc. So this combination type right here, it looks at series number one and parallel arc. Looks at series and parallel arc. A series arc, guys, is here's a parallel arc is here's a hot one and here's a neutral, and you're arcing between these two. That will be my parallel arc. My series arc, it would be, let's just put let's break it from right here. If you're arcing here, you break this hot and you're arcing in series here because of connection, so that will be your series arc. Long story short, it looks at the complete arcing business, parallel or series. Any question, guys, about parallel combination type? Parallel series? Where do you need an arc flow circuit interrupter? So you have to install it to protect, guys, the branch circuits and everything else. Now, Ashley, if you decided, Chad, the idea is you need to protect, you put the arc flow circuit interrupter here to protect the circuit as well as the receptacles. Now, if you decided you want to have a device interrupter installed to provide protection for the branch circuit. Now here's an exception here that they give you guys, one exception. If you decided, for this exception, if you decided to wire it with conduit, EMT, so here's my branch circuit right in here, 20 amp, I put my conduit here, all the way to this box, metallic box, then I can put arc full circuit interrupter right in here. So this will be my arc full circuit interrupter. Long story short, if you wire with conduit, they allow you to put a circuit, a receptacle as an arc full circuit interrupter, not the circuit breaker. But you have to wire with conduit. How often do you really use rigid? In residential. Talk about residential. IMC, are you kidding me? EMT, maybe. MC, I could see an MC. Or AC cables. So take this. If I'm wiring an NM cable from here to this receptacle, the circuit breaker has to be an arc full circuit interrupter. If I use an MC cable or AC cable or EMT conduit and conduit it from here all the way to here, then I have two options, either the arc full circuit interrupter circuit breaker there, or a device that does not exist yet. That's called arc full circuit interrupter receptacle. Any question, guys, about this? Any question about this?
Or if you put a GFCI on you don't have to have both, right?
If take this. See, I'm in a bedroom, and I decided as a chat security in that bedroom to put GFCI receptacles here. Now, bedroom outlets need also arc full circuit interrupter. I must have arc full circuit interrupter too.
So then you could have an arc fault circuit breaker?
Yep.
Okay.
And feed the GFCI.
But you do not, you can just have an arc fault circuit breaker. You don't need the receptacle also.
As an arc fault?
Yeah.
No, yeah, either or.
Okay. Yeah.
The only option, the arc ground fault circuit interrupter and arc full circuit interrupter are two completely different things. They look at completely different things. So, but if you, for example, in the kitchen, I do not need by code an arc full circuit interrupter in the kitchen. So my countertop receptacles have to be GFCI or GFCI protected, no problem. I can protect them from a circuit breaker or from the devices here. Now, if I decided to put an arc full circuit interrupter on them, the only option right now in the market is to put an arc full circuit interrupter circuit breaker. Any questions, guys, about the requirement for arc fault circuit interrupter? So I thought to highlight this before we get quick into. I want you guys to highlight these locations before we quick get into the a few other things I would like to highlight. The most common, this chapter, guys, talk about protection. There are, in the electrical industry, there's so many types of protection. The type that I want to talk about is ground fault circuit interrupter, type A, and arc fault circuit interrupter. They have immersion detection and appliances leakage. I don't know how many of you guys, these are manufacturer provided equipment. Appliances leakage current interrupter and immersion detection circuit interrupters. These are, we don't provide them most of the time. They are part of the plug that you have. So long story short, if you have, have anything, if you have a plug that you're using close to water, like grooming your hair or something, and you drop that appliances while energized in water, that device will de-energize. That immersion detection circuit interrupter will de-energize the equipment before you get electrocuted. So if you decided to use your grooming equipment while you are in the bathtub and you accidentally drop that baby right into the bathtub with water in it, and two other things could happen. You could go completely electrocuted, or the equipment have that little device at the end. It senses that it got immersed with water and it trips fast enough to protect you from going to the second life. Any questions, guys, about this? So these two, the last two, we don't really take care of them a lot in the design. These are the ones that we dear to our hearts and we do all the time. Okay, so we talk about arc fault circuit interrupter. As I said, the most important things, this is, I show you guys where in the code it talks about these. These two are appliances related. We don't install them, so to speak. So that's what we're going to go directly. Existing requirement, we'll talk about tamper. Another thing, guys, I want to talk about when tamper resistant and weather resistant. In residential, in 2011 code, there are 4 things for receptacles we have to be aware of. They could be either GFCI'd or arc fault circuit interrupter protected, these two, or all of them have to be tamper resistant and weatherproof. If weatherproof only if they're installed outdoor in wet location, tamper resistance everywhere. Did you guys hear me? You have to have tamper resistant receptacle, weatherproof if they're installed on elsewhere, outdoor in wet location. But GFCI or arc fault circuit interrupters depends where the location that we highlighted, certain location where you need them. So please be aware of that one. We'll talk about surge protective in a second. We're going to go directly into the shock. The whole idea, guys, without getting into the literature of it, the whole idea, when you have protection, here's your circuit, and here's your receptacle, and here's your equipment plugged into this receptacle, and here's yourself, right? Using this equipment. Oops, from here, not with your eyes, I guess. You have to use it with your hands. Okay, so if as you using the outlet, I have a 20 amp circuit. Here's my receptacle. There are a bunch of protection that you need to protect the people, bunch of them. Let me count a few. Either or. Number one you need is overcurrent protection device. This is short circuit and ground fault. In this circuit, which device provide me with a short circuit and ground fault protection? Which device? Which device? If you're looking at this circuit, guys, which device provide the short circuit protection and ground fault protection? Circuit breaker. This is your circuit breaker. Circuit breaker. So the first protection is provided by, it's called overcurrent protection device. It will provide you, if there's a short circuit, so if I grab two hot and a ground and hold them together, it will trip. A hot and a ground, it will trip. Okay, so protection number one that you have is what? Short circuit and ground fault from the circuit breaker. So that's protection number one. Protection number two, my friend, that you could have is GFCI protection. GFCI protection. GFCI protection, 6 milliamps.
You explain ground fault on number one.
Oh, ground fault. Here's a hot, and here's the ground, and you short them. The ground.
It's the same as the
Yeah. It's the same as short circuit in a single phase, almost. The same, if three phase, it becomes a short circuit, and three phase to phase too. In a single phase, the ground fault is line to ground or line to neutral too. So that's protection number one. Protection number two, ground fault protection. What the GFCI does protect you from, as I said, a kid plugs something into the outlet, and instead of the current going right through that kid down to the ground, complete the circuit, and you kill that kid, that GFCI is looking at the current that's coming in, coming out. If there's a difference of 6 milliamps, trips. So your second protection is what? Ground fault circuit protection. Your third protection in the same circuit that you're looking at, guys, your third protection is arc fault circuit interrupter. Arc fault circuit interrupter, if the equipment here start arcing and sparking, you plug in things here and your equipment start arcing and sparking. Why would I arc? How would equipment arc? If you have loose connections, it's not a short circuit, it's just not connected right, it starts arcing. When you arc, guys, you create obviously fire and heat. Heat create fire, and fire burn buildings. So the arc fault circuit interrupter is supposed to protect you from fires, not from short circuit. Okay, so here's the third protection that you're going to have. The fourth protection, believe it or not, the fourth protection that we have is tamper resistant. Tamper resistant, I showed you guys the receptacle. Tamper resistance is you will protect a kid from putting basically one paper clip right into the hot and get electrocuted. So if you put, like I showed you the other day, I gave you a tamper resistant receptacle. In order to engage the receptacle mechanically, you have to push both the hot and the neutral. Here's your fourth protection in this circuit, tamper resistant. The fifth protection on this circuit, and the last one, believe it or not, the fifth protection on this circuit, my friend, is weather proof. Weatherproof receptacles. Weatherproof receptacles, guys, in only wet location. You sit the receptacle outside, heat and cold, and all the rays, the sun rays are beating on these receptacles. If it's not weatherproof, it's going to fall apart. What's the danger if it fall apart? If you need to maintain it or do something, you go open it and the whole thing, the insulation will fall apart in your hand. You could be electrocuted. So if you have weatherproof, almost not guaranteed, but your chances of maintaining this receptacle for whatever reason, later on, 5 years after you install it, you most likely will going to find the receptacle intact in wet location. Any question, guys, about one circuit has 5 protections. One circuit has 5 types of protections. Now you can have all of them or you can have some of them. In residential, guys, you have, here's the must. Let me highlight the must. The must have in red. This is the must. You must have this. For every circuit, you must have overcurrent protection device. You can't just go without it. GFCI, we know where the GFCI is located, almost in every wet or damp location, and we listed the location. Arc fault circuit interrupter, almost in every location that doesn't have GFCI, you need an arc fault circuit interrupter. In residential, tamper resistance is a must, and weatherproof is a must. So you have 3 of these protection for every, tamper resistance is a must. Weatherproof should be in wet location, only wet. If you have wet location, you need to have a tamper resistant, weatherproof receptacle. Any question, guys, about these 5 types of protection for one circuit? 5 types of protection. Who cares about these protections? It's supposed to protect us as a human being, either from being electrocuted or burning our homes, right? Look at all of them. Short circuit, burn homes. Ground fault, burn homes if it doesn't work. Arc flash, arc fault, burn homes. Ground fault protection, protect us from being electrocuted. Weatherproof, protect the equipment. And by protecting the equipment, protect us, right? Weatherproof and tamper resistance protection from kids or anybody tampering with the receptacle. Any question about these 5 protection that you need for most of the receptacles and the outlets in every residential? Yes, Dustin?
I have a question about GFCI protection.
Okay.
Like, let's just say in your kitchen, countertops, if you put a GFCI breaker on that receptacle instead of a GFCI receptacle, is that
legit? No problem.
No problem?
No problem.
You can have all regular tamper resistant receptacles or whatever.
Tamper, yep, with GFCI circuit breaker.
GFCI circuit breaker.
Yep.
That's okay.
Yeah. Did you see any inspector? You might, yeah. Yeah, go ahead.
Would you want a weatherproof receptacle underneath the sink?
Weatherproof receptacle underneath the sink? No.
No. Well, I'm just thinking.
Weatherproof is when it's exposed to the elements mainly.
Okay.
It's usually damp, not wet location.
I'm just thinking about the plumber if he screws up.
Yeah, but wet location, guys, could be, wet location is saturated with water. Damp and dry location occasionally could have water. This, as I said, this floor is wet, is dry location. But when I wash it, becomes wet location occasionally. So when we're talking about normal situation in the winter outdoor, it's a very wet location, and in the summer in Minnesota too. Any question guys about these 5 protection?
On the text states that it will only operate properly on a grounded system. If they have knob and tube, are you out of the picture?
Which one are we talking about now?
GFCI.
The ground fault protection. The ground fault protection.
The diagram doesn't indicate anything.
Yeah, the ground fault protection really we installed them in an ungrounded system like nub and tube. The ground fault protection, the electronics in is supposed to look at the current that comes in and the current that comes out. If there's a difference of 6 milliamps or more, it trips. So if the system is grounded, it's okay. If the system is not grounded, it's okay too. As long as you can capture what's coming. The problem with the nub and tube, if you put a nub and tube, they're sharing neutral. So you have to put it in the right location so you don't nuisance tripping with it. Because the neutral, especially if you put a circuit breaker, the neutrals are all over, coming from all over circuits. So I'll show you a couple of diagrams. Any questions guys about this? Yes, sir.
If you're protected by GFCI receptacle, do you have to have a receptacle that's tamper resistant?
Yes. In dwelling. Remember, we're talking about dwelling here. Yes. All the receptacles in dwelling units have to be tamper resistant. All of them. GFCI, arc fault, all the receptacles. All of them. Indoor, outdoor.
Unless they're over a certain height.
There's exception in 2011. Thank you. In 2011, they had exception for tamper resistance, guys. Exception number 1, if it's higher than 5.5, was it 5.5? Okay. If it's higher, if you have a plasma TV there and you have a receptacle higher than 6 inches, 5.5. I think it's 5 feet 6 inches. Number 1, if you have a dedicated receptacle for an area, like the one for the garbage disposal, does not have to be. That's 2011. If you have a lighting fixture that has a receptacle in it, that doesn't have to be. If you have a cabinet, and inside the cabinet you have a receptacle for the microwave, doesn't have to be tamper resistant. Or if you're replacing old receptacles, they also don't have to be tamper resistant. So these exceptions came in 2011. Dedicated space behind the non-accessible, don't have to have tamper resistance. The height 5 feet 6 inches, don't have to. If you have them in a lighting fixture, part of a lighting fixture, you don't have to. And the 4th one, if you are replacing a non-grounding receptacle, they don't have to be tamper resistant. All other receptacles have to be tamper resistant. GFCI, non-GFCI, the same. Any questions about that? These are just in 2011, these exceptions came to be. Good point. And here's it talks to you guys about the characteristics of the shock. Obviously, if you have an electrical shock, I counted probably 20 plus times I got electrical shocks. It depends upon the characteristics, the body resistance, the contact duration, the bath, the humidity. Long story short, if you want to go to the second line fast, all what you have to do, grab onto a 120 hot conductor and barefoot and sit in a pool of water. That will send you to this end. Just grab, don't touch like this. Just grab it like this. Sit in the pool of water will take you directly to the other. That's called the perfect shock. Perfect shock because contact with your bare hand with a hot conductor, contact with your foot, barefoot, with a grounded system. And of course, if you're skinny, also that will help to go faster. If you're fat, by the way, the fatter people are chances is higher. Oh, that's the only advantage of being fat is when you get an electrical shock, you can handle it better. Another advantage of Ashley is being a male too. Male will handle the shocks higher amps than females. So that's what they're talking about, the characteristics, guys. And of course, if this is 120, imagine if this voltage is 480. If I grab one phase here and one phase here like this and grab on them and 480 in both hands, that will send you immediately to the second line. You are acting as a 3-phase motor, basically, a single phase motor between 2 huts. So that's what it talks about, the characteristics, guys, the contacts, and the path that goes with it. Like they said, going from hand to hand through the heart, done, completely done. So that's a few things about the humidity and the resistivity of the body and so forth. The key point is, guys, systems. If you have a system, voltages, generally speaking, of 50 volt and greater are considered lethal. But any voltage is dangerous. Any voltage is dangerous. I mean, even 50 volt at the right amount of amps is dangerous. But higher than 50 volt become, what's the word? Lethal. So the common voltage that we use in utilization AC is 120. Lethal. And the system has to be grounded by code if it's more than 50 volt. Voltage 50 volt and greater are considered lethal. So if your system is more than 50 volt or more, you have to ground it. Grounding system. Okay, here's a nice graphic, guys. It will tell you 6 milliamps. Can you guys see that 6 milliamps? So your friend Chad, here's my hot, and here's your friend Chad is standing, grabbing on this hot, and sitting right over here. There's a pool of water right here. Okay, so ground fault protection. If you are to grab on a hot water, a hot and the ground, and will ground it, and you have a GFCI, the GFCI will trip within 6 milliamps. 6 milliamps, guys, is enough to not kill you. So if you have a GFCI, the GFCI will trip. If you have a circuit breaker like this, you don't have a GFCI, a circuit breaker will trip, but not before you go to the second life. You see the difference? It will trip eventually, but you will be dead by the time it trips. You wouldn't know that it tripped. People will pick you up, probably they would know. Can you see the advantage of why GFCI is a big deal? Put GFCI in system. In a second life, I'll show you another system. But this is basically what, and they give you this is where the lethal. The last thing you want to do is allow 24 milliamps to go through your system, and you get into this red area. This is the amps. The higher the amp, the more dangerous. The faster you trip, we trip from here to here. Look how fast they trip. Very fast. The tripping is very fast. And we consider milliseconds. Approximately 0.035 of a second. That's fast. Trip fast. If you allow it, here, take this. If you have 180 milliamps and keep going all the way up to allow it, this is in seconds, 1 second. Allow 180 milliamps 1 second, your heart will stop.
How do you explain the electric chair? You ever watched an execution?
I don't like to do that.
No, I mean, they grease the guy, they shave the guy, they grease his head, they water him, they connect him to an earth ground, and they flip a switch, a very high voltage, and it takes a while.
To cook the individual. To cook the individual.
Yeah,
1 second. More, okay. It doesn't stop your heart, but I don't know how they do them. But I'm not really.
Slam bam, put him in the tub, hand him a hairdryer, and he's dead.
Well, no. Well, it depends on. Well, here's what it. At least I've never tried it, and I hope nobody will ever try it. If you bring a current right through your heart, like you grab hand to hand and goes right through your heart, and you're not grounded anywhere else. So if the current starts to go through your feet down to the ground, you're not grounded. You know, that probably will be lethal. How long will it take you to die? I don't know. Here's the graphic that they're telling us. If you put 180 amps based on statistics that they have done, they came up 100 milliamps, you will die in 1 second. Now is this, well, it started the death in 1 second though. It might take you 2 seconds here or so to go, because that's a range. But the key point, guys, the key point is we trip so fast, very fast, and we trip at very small amount of current to protect us. Any question, any comments about that? Questions, comments? If you have from 50 to 1,000 volt, the systems have to be grounded, and we know why. I told you guys before, for electricity to work, you need only one hot and Mother Earth. To work efficient, what do you need? Neutral. To bring the current back, efficient. To work safe, what do you need? A grounding conductor. So if accidentally the hot accidentally touch the frame of the object or the equipment, and you come like a fridge in the basement. It happens all the time. There's so many wires in it. One hot accidentally touch the frame of the fridge. You go grab the fridge barefoot like my wife would do in the basement, and barefoot in a damp basement, what's going to happen? That's a perfect shock. And you get 120 from the frame of the basement directly through your heart down to the ground. It could send you to the other life fast. So that's why we have a grounded system. Grounded system enhances, and I'll talk about what the difference, guys, between grounded system and ungrounded system and grounding system. This is later on, but almost 99.99 of the system that we use in residential is grounded system. There's reference to the ground. We went, guys, to here and we highlighted all the locations, right, that you need a GFCI protection. Everybody knows what the GFCI protection required. There are two ways of providing a GFCI protection, three ways of providing a GFCI protection. Here's 100 amp ground fault circuit interrupter, or here's a 20 amp ground fault circuit interrupter, or, right, let's just say a receptacle here, ground fault circuit interrupter, receptacle. There are three ways of providing ground fault circuit protection. 99% of the time, or 90% of the time, you have a ground fault circuit interrupter in the US, here. Sometimes we have a ground fault circuit, a ground fault receptacle, ground fault circuit interrupter, a circuit breaker, and sometimes you have a main. The main is circuit breaker. The main, not commonly used here. In other parts of the world, they use the main. They put a GFCI on the main. Did they tell you about what I used to do when they put them in the main in Jerusalem? Take this. If you put a ground fault protection on the main right here, now what happened? Ground fault protection is looking at 6 milliamps. These are all 6 milliamps in the US, 6 milliamps. In Jerusalem, these are rated for 30 milliamps. They're higher. Tougher people, I guess. Higher. So even 30 milliamps, guys, if you put them at the main, right in here, in the winter, wiring and things, there's leakage, earth leakage to ground. And there's current that goes in the conduit to ground, small little amount of current that goes. Long story short, when you put it at the main, all the leakage and all the branch circuits add up here to more than 30 milliamps. So then they call your friend Chad here. They say, well, we keep tripping Chad on a ground fault circuit interrupter. So what your friend Chad used to do, go to this device here and bypass it. Come from here, you bypass it. So now you bypass the ground fault circuit interrupter. It's illegal, but you know, what are you going to tell them? Fix the dampness in your basement so you can't watch your favorite show tonight because you have dampness in your basement? Or we can bypass it for you until you fix it, whenever. The funny thing is still a lot of homes, when I go back to visit, a lot of homes are still bypassed. That was 20 years ago. Anyway, any question about the ground fault circuit interrupter, guys? You can have a circuit breaker, you can have a receptacle, you can have the main as a ground fault circuit interrupter. Any question? Okay, required for... this is the exception that I told you guys. Exception for security system, burglary alarm system. If you have one receptacle in the basement dedicated for the burglary alarm system, it doesn't have to be on GFCI. You can use, you can meet the code by circuit breakers or GFCI, like you said. Feed through and test for GFCIs. A couple of pictures I'll show you later on. Arc fault circuit interrupter. We know the difference between GFCI and arc fault. Arc looks at the arc in series or in parallel. In series or in parallel. Okay, trips, it has an electronic brain that looks at the signature of an arc. Here's the signal. Here's the beautiful signal. If I have an arc in the signal, my signal might look something like this, and I'm creating this from my memory. So the smarter than Chad device, arc fault circuit interrupter, circuit breaker, looks at that signal, analyze it electronically, and come up with a decision that, guess what? This branch circuit must have a what? an arc fault somewhere. So what do? You trip. So that's basically what's looking at. Looking, if it doesn't trip, what could happen? Arc, heat, fire, and so forth. Okay, we got that one. Here's the location. This is a really nice place of summarizing the location for arc fault circuit interrupter. We went through it and highlighted in the code, guys. Basically, think of it as any place that doesn't have GFCI. Do I need arc fault circuit interrupter in the garage? No. Outdoor? No. Unfinished basement? No. Bathrooms? No. Kitchens? No. What else? Crawl space? No. Attic? No. Do I have an attic? No. I thought it's attic? No. Any question, guys? Any question about that? Okay, dining table. How about laundry room? Do you see a laundry room? You guys see a laundry room? Do I need it in a laundry room? No. No laundry room. So these are the places that you need them. Tamper resistant. We talked about tamper resistant and weatherproof resistant, guys, in damp and wet locations. I want you, please, to go with me to code rules 406.4. This is what talks about the dam. If you go, please, with me to 406.4. 406.4. Okay. Installation replacement. Receptacle, existing two wire receptacles, grounding. If you guys go there, it will tell you a few things. It will tell you if you have an up and tube fail and you need to replace that up and tube receptacle non-grounding, how can you replace it? I'm sure you guys have seen that. If you want to replace an up and tube receptacle because it doesn't have a ground in it, here's the option. Number one, replace it with a non-grounding receptacle. Chad, well, that doesn't solve my problem. Number two, you can replace it with a grounding receptacle if you provided equipment grounding conductor here. So it will basically pull a branch circuit. Number three, which a lot of us did, guys, in the past, is you put a GFCI here, you replace it with a grounding receptacle GFCI, and on it, you write no equipment grounding protection. GFCI protected, no equipment grounding protection. So that's the method that we use for grounding them. All these are in 406.4. You guys are not electricians, so it's not going to apply a whole lot to you. Temporary wiring. For temporary wiring, guys, and construction, we talk about construction as we move on. All the 15. If you're on a construction site, Phil, all your 15, 20 amp, and 30 amp, 120 and 240 must be GFCI protected. So what do? They have these portable GFCI protection equipment, and you plug them in. Your equipment in a construction site have to be GFCI protection. Most of the time, you have this portable ground fault protection circuit interrupter cord sets, where you can plug in and get on the construction site your ground fault protection. IDCI and these guys, again, I don't like to, these are appliances related, like the grooming appliances. The idea is Chad Kennedy is grooming his hair, and his wife yelled at him, and the sink is full of water, and he got mad, and he dropped that grooming device right into a sink full of water. Two things could happen. It could have big arc, and if I'm closer to it, I can get electrocuted. Or usually they have this big, you see the plug is big. Right inside it has an electronic device that looks at this scenario, and it trips. So if you immerse an appliances in water, instead of electrifying the whole water and anybody in the water could be dead, this device will trip. Now, we don't install these, the manufacturers install them in equipment. So that's as far as you guys are concerned. Temporary wiring, guys, a couple of things in temporary wiring. You have your ground fault protection here in all your 15, 20, 30 amps. The last thing is a surge protective device. Before I show you a couple of pictures here. Surge protective device, take this. Here's the signal. Here's my beautiful signal that I'm supposed to have. And because the lightning hit the transmission line, there's a big pulse came into from the lightning, hit the transmission line, went to the distribution system, down through the transformer, into my building. And look what's going to happen. See that? Beautiful. I'm going to draw that one in. So I'm going good, up to this point. Now I went all the way to the Lord, and I came back and continued. And I went here all the way down to the Lord, came back and continued. This is a transmission line got hit by a lightning. Big spike. Look at the voltage. If your voltage is supposed to be 120 volt here, this up here could be as high as a 1000 volt. But look, for a very short amount of time, right? That's a transient coming from a transmission line, switching transmission lines, or lightning hit the transmission line distribution system coming through your building. There's a lot of protection, guys, on these lines too. Or it could be, guys, the air handling unit here at Dunwoody, we switched the air handling unit and it created all these pulsation into my system internally. Long story short, so what happened if I dump this signal right into your laptop tower? If I dump that signal with the pulse going all the way to the Lord and coming back, it's going to burn your equipment. So what the Smarter Than Chad design an equipment called surge protective devices. You know what those guys do? They put them so close, they put the hot so close, the device, they put the hot so close to the ground that if the voltage goes higher than what needed, it jumps the gap between the hot and the ground, and it shunts all this voltage and take it to Mother Earth. Here's what happened. That device takes this pulse, can you guys see this pulse, and cut it right here. We don't want to see it. And takes this pulse here and cuts it. So only for a short amount of time, it takes the phase and shunt it to the ground. And take all this voltage, take it to Mother Earth. Very short amount of time. By doing that, you're going to end up with a signal. Every time it comes up, if there's a pulse, it cuts it. So my signal continues to be nice sinusoidal wave for the most part. Any question, guys, about surge protective devices? We'll talk a little bit more about them as we go in the commercial industrial because we specify them more in the commercial. They can come as a circuit breakers or they can come as receptacles. A device, we bring them as a device, guys. You plug them in here. If there's a lightning protection in residential, it's supposed to protect your plasma TV and your computers and so forth. Any question, guys, about SPD? In residential, not code, recommended. Engineering-wise, when we move into commercial building, we specify them at the service. Every service commercial building, we specify a surge protective device right at the service. In residential, we don't specify them. It's recommended to have a receptacle. Most of the people have that strip, what do you call the strip? Power strip, thank you. They have a power strip that has all these devices in them, the power strip. So that's what most of the people in residential do. Any question, guys, about the surge protective device? That's the most important one when it comes to commercial industrial. Any question about that? And if you think this is enough, I'm going to give you 5 minutes break, guys, in a second. If you think that protection is a lot, wait until you do medium voltage. You can count, my friend, close to probably 22 protection that you can do in a medium voltage system. From high, low voltage, into frequencies, into all this good stuff. Okay, let's have 5 minutes break, guys. If you want to do power system analysis later on in the spring, this is a big deal. You get used to curves like this. Very interesting. Since we're residential, I just want to mention that here we're talking about the current I here, and here we're talking about the time. The time. Obviously, the more, look at that, the more current you have, the faster it will trip. The more current you have, the faster it will trip. And this is the tripping mechanism for my GFCI. And I know Christian can argue with me, but they supposedly, if you go from here, here's 180 milliamps, up to here, and you cross-reference it, oh gosh, I don't know if I cross-reference it here, that will get you, say, 1.5 second. Within 1.5 seconds, they're going to join Jesus Christ, directly from here. If you that's where your destination. If you have other destination, you can join that destination too. Supposedly, based on statistics. You know what I mean? So it will take you, if I go probably here, so I say take maybe a second between getting here to joining the Lord or the Lords. So give or take. This is really, pay attention to this one because this is when we do short circuit analysis, guys. Time current characteristic curve, big deal. So for the time being, just remember your GFCI friend is right here. A few people, guys, like the one that I installed in Jerusalem sits right here, guys, which is 30 milliamps. 30 milliamps. It still gives you protection. Look at that. If you have a 30 milliamps, it still protects you. It allows trips at 30 milliamps. They're good protection. I mean, but it still gives you good protection. But trips at more amps. Okay, so that's why I wanted just to mention a few things about that. Go here. GFCI, if you are with your friend Chad Kirby right now, and this is a kitchen, everybody knows that every receptacle right here in this kitchen has to be GFCI, right? All the receptacle on the countertop and the peninsula and the island of a kitchen have to be GFCI. Receptacle within 6 feet of a sink have to be GFCI. So GFCI, so suppose that this guy is 10 feet. This guy doesn't have to be GFCI, but this guy has to be GFCI. If it's a sink, not in a kitchen, that's my bar sink. So I invite my friends in the basement and we drink pop and Pepsi and all this good stuff. So if it's within 6 feet, GFCI, further than 6 feet, not GFCI. Nick, it's a good idea though. This is what the code says. It's a good idea if you have a bar sink. You don't need to have a receptacle for a bar sink, by the way. But if you put receptacle there, bar sink, not a kitchen sink. If you put a receptacle, good idea to put 1 or 2 receptacles. A great idea to put them always in GFCI, regardless of a distance. Okay? But the code say only if it's 6 feet from a sink.
But then it would need AFCI. No. Well, actually, both of them.
Very good point. Now take this. What if this wet bar in a finished basement? Take this. It's a wet bar in a finished basement. So take this. So this receptacle is going to be GFCI because it's within 6 feet. And also I have to put this baby in arc fault circuit interrupter, and that's okay with that. That's okay. I was talking to Tao during the break, and I told him that when you guys go commercial industrial, we have a 4,000 amp switch, 4,000 amp circuit breakers. Imagine 2 feet by 2 feet by 2 feet. That's how big that boy is. And that circuit breaker, actually, you can dial it from your laptop, pull all the information from it, the current, the voltage, the frequency, the harmonics. You can ask that circuit breaker to open or close. So my point is, I want you guys, as we move into commercial industrial, to get out of your mind the circuit breakers are only tiny little pieces like these. You know, these are the lower end of them. Circuit breakers can go, they can become a control device, and they can pull as many info as you want as you go higher in amps. So that's why I can eventually, probably you'll see a circuit breaker that has right here. That same circuit breaker can give you, right now, this circuit breaker can give you overload protection. Remember the overload? If you have if this is 20 amp and you pull 30 amp out of it, what happened to it? Trips. It gives you short circuit. And number 3, it gives you ground fault. The same thing like short circuit in a single phase, short circuit, ground fault, same as short circuit. And it gives you also number 4, arc fault circuit interrupter. It has an electronic device in it, very smart, intelligent, that looks at the arc and trips. Now I can add more functions. Chris, when I start doing medium voltage, the first thing I have to change in my mind is a circuit breaker is a multi-function device. This is, they call the overload 1 function. Each one of these is a function, meaning a function meaning it's part of the circuit breaker. It could be designed, added to the circuit breaker, and utilized. Anyway, so that have to be, if it's in a basement, it has to be arc fault as well. Moving on, we talked about the ground fault circuit interrupter, guys. GFCI is only required for outlets, not lights, for receptacle outlets, not lights. But if you put them in a branch circuit, obviously, it will protect the lights and the receptacle, which is okay with that, no problem with that. This is the most common way of putting ground fault protection in the US. You provide it right at the, what's the advantage of putting it right here, by the way? What's the disadvantage of putting it on a branch circuit that has light on it? If you trip it, what's going to happen to your light? Gone. By the way, can I put the lighting circuit in the kitchen on the same receptacles? No. These two small appliances circuit in the kitchen are circuit cows. You can't feed anything from it. No lights, nothing. With very few exceptions. Okay, so moving in here, we can have a ground fault. This is, as I said, more common overseas. I've seen it. This way where you have at the 100 amp level, you have a ground earth leakage device. You have an earth leakage device mostly rated for 30 milliamp. So when Ch6 Ericsson start working on, the reason why I mentioned this, some of you, Rob sitting there said, what the heck, why do I give, what's going on overseas? We were at Ellery Beckett, guys. We were doing work in United Arab Emirates and for the U.S. Army and for a couple of other places. So we are closer to the international community than you think. So it's good to know a few things, that how they do things differently, earth leakage and so forth. So that's why I mentioned these ones. You could be sitting at Ch6 Ericsson and doing a hospital like we did at Ellery Beckett hospitals in Dubai or in South America, in any other places. So that's why it becomes, this is a little bit, at least my experience with it, a little bit overseas. I haven't seen it here a lot. Here's the ground fault protection, guys. You've seen it with, I'm sure you've seen it before. This is the single most important thing about it. And I have my friend Chris here, programmer. That's it. That's your non-programmable solid state circuit, the brain. So this baby, it's really all what it does, it's looking at the amps in and the amps out. And if it sees a difference of 6 milliamps, it will send the signal to this, it will send the signal here, tiny little signal, to this shunt trip, and that shunt trip will push the circuit breaker mechanically, physically, bam, and open it. That's what it does. It's looking electronically at the current in and out. So here's your friend Chad goofing around here. And if this is energized, and so you have, I don't know, what you have, 6 amps here. If you have 6 milliamps, look at that. You have 6 amps going on. It came back. Look how small the one that came, 5.994. Very small amount came back. Very small losses. That losses went through your friend Chad down to Mother Earth, into the source, as it should. The circuit breaker will see this 6 milliamps, and what does it do? Trips. As I said, it's very fast, and so forth. In other places, they 30 milliamps. The same concept. It will allow 30 milliamps. Any question, guys, about how the system works? Electronic device in, out. Being electronic, they malfunction, so you guys have to be very careful. You have to test them all the time. In your book, there's a list of testing. You're supposed to test them monthly and make sure they're working. And you put a GFCI for 5-6 years. It might not trip when you need it. So it's a good idea from time there's a test there to test it, make sure it works. Okay, here's, you guys have seen GFCI, the test, where you can push the button to test it. Very important. There's a couple of pictures I want to show. Ground fault protection. I believe this is a picture of GFCI. 20 amp. Does it say where somewhere is this? Yeah, this is your GFCI circuit breaker. GFCI circuit breaker. Sometimes the arc looks like it. Do I see here? QP, the most common ones.
I think that was wrong.
Is it arc?
I'm looking at the arc.
Is it? Am I looking at the wrong one here? Ground fault circuit eruptor, ground fault circuit eruptor. No, that's a GFCI, the one I'm looking at right now.
Oh.
That's a ground fault. Okay. Ground fault feed through, guys. Everybody know how to ground fault system works, right? You bring, if you haven't wired the GFCI, make sure we wire you with one. I have actually, here's my hot, here's my neutral. You come with another neutral and another hot out. This is my load. This is my, I'm sorry, this is my load. This is my line. Right? Line. Mistake number one, what comes in the line, you can't share the line neutral with the load. That's where a lot of people have nuisance stripping. You can't share the line neutral with the load neutral, or the line hot with the load hot. Meaning, the minute that they come in, you can't tie this to this or this to this. You defeat the purpose. You're supposed to come in. This is where we meter you guys. This is where the metering equipment happens. You get metered and you come out. You can't bypass the meter because it defeats the purpose. Now the current is not being seen. Okay, I said that's feed through GFCI protection, guys. You grab a GFCI and you feed all the rest of them from it. Cheaper installation. What's the disadvantage? I always say this example. I was on a service call, guys, one time in Plymouth. So I went there. The owner, I did work for the owner, and he said, "Chad, their circuit breaker is not working." So I on the phone, he's a friend of mine. I said, "Why don't you push this, push that?" No, it's not working, Chad. The first thing you say, go reset the circuit breaker. Is it GFCI? No, it's not a GFCI, Chad. It's outside, but it should be a GFCI, right? It's an outside circuit breaker receptacle. It should be a GFCI. Go to the circuit breakers, nothing. So when I went there, drove all the way there, charged him a certain amount of money, and you know what the issue was? There was a basement, a walk-out basement, and the electrician wired put a GFCI in the basement, which is now finished. So you can't tell if that was, at the time, it wasn't finished. Now it's finished, completely finished, and there's a GFCI receptacle, and there's equipment behind it. And from that GFCI receptacle in the basement, he is feed through a receptacle outdoor, which is okay by code. So the GFCI receptacle in the finished basement with a lot of equipment behind it tripped. The owner doesn't know that there's a GFCI. I should have thought to tell him that there's a GFCI, but he said it's finished basement. I didn't know when it was wired. So if you were to do something like this, if this is GFCI protected and this is my GFCI, if this trips, you lost this. So if you're troubleshooting here, not knowing that this is fit from a GFCI indoor, it's a learning experience. You might have to just keep this in mind. I learned from it to look for other locations. So feed through. What's the advantage of feed through cheaper equipment? What's the disadvantages? Is so many eggs in one basket. So you lose one, you lose a lot. Here's exactly how you should wire it. You bring your line over here. This is your 20 amp circuit, and you bring your loads to all the other equipments right in here. And you keep going from here to here, and from here to here, and so forth. If you do it other than that, you can't grab the hot from here and tie it to here, or the neutral from here, tie it to here, or you grab the neutral from here and the hot from here and feed a piece of equipment. Can you do that? It will trip and defeat the purpose. Any question, guys, about the wiring? And you wired a few of these with us, so it's not new to you. Here's the feed through line load. Always, when you wire it, you look at the line, bring the circuit to the line, load, bring the load to what's going to be fed through. This is what we we're just talking about, improper installation, guys. When you steal things to feed it, as you can see, this is the proper way. The proper way is the minute that you want to come in. See that? This is kind of the barrier. Anything from this side of the circuit should not be tied to the other side of the circuit, right? How can I? Here's my question for you guys. How can I make this one proper? How can I make this installation proper? Here's my question for you. I don't want this light to be in a GFCI. I do not want this light to be on a GFCI. I don't want it. And I want to feed it from the same circuit, the same 20 amp circuit.
Connect it to the line.
Absolutely. Grab this wire from here and take it all the way to where? To the line. And get rid of this. That's okay. Now the second receptacle is GFCI protected. The light is a non-GFCI. Where would that be a good idea if you are doing in a kitchen, if you're feeding the receptacle for the fridge receptacle? That's exactly how we do a fridge receptacle. You put your receptacle, of course, no switch here. This is fridge receptacle. That's how you come from the line side and you go feed the fridge receptacle, but from the load side, you continue feeding other things. So what happens if this trips? If this is tripped, you lose these two, but this one's still up and functioning. That's a good application for a fridge in a kitchen. Any question, guys, about this? Now remember, we are measuring what's in and what's out. If you come from here and tie to the load, from the line to the load, you will trip because it will trip instantly because you're screwing up the balance. Any question, guys? Any question, my friends? This is what you're supposed to do, Phil, my friend. You go to your wife and tell her, take this, print it, and keep testing all these and put your data. January, February, every month, you test them. Can't remember the last time I tested mine. Anybody test them? Ashley, do you test that? The other night, I was just next to the circuit breaker because I thought I'm going to push that thing that makes it in my house, and it works. But you're supposed to test it monthly. Bet you my son will be excited about that. So type, this is QP, this is the arc full circuit interrupter. Let's see, 75. I think this is my 70K test 120 type QP listed, also classified as meeting hacker type. Okay, right. Is it? Okay, they always look. Yeah, it's arc full circuit interrupter. They always look alike. This is my arc full circuit interrupter. I want to bring to your attention, this is the most common, guys, QP, square D, QO, square D. I want to bring to your attention, if you look at it, really, I like the hacker. Can you guys see the hacker here? Everybody can see hacker. This means it's also listed to be installed in HVAC equipment. That's almost all the circuit breakers will have that one, hacker, very important. And the last thing, yesterday somebody was asking me about this temperature. Can you guys see the temperature here? Can you see it? It says 60 degrees / 75 degree copper, aluminum and copper. So the copper will be, if you're putting copper, there will be 75 degrees. Who asked me yesterday? We said, remember the rules that I told you? Yeah. So you can see it directly if you're installing copper on that baby, which is most of the time at this side we put copper. It's rated in this side is 75 degrees. So I can size the conductor 75, but what's my problem is the other end. Can you guys see that? This is really interesting. And where do you install? Your hot comes in, tied here, and your neutral will be in that area, and off it goes. It measures the current. The same thing is, this device needs a neutral to work on. It looks at the neutral and the current coming out of this equipment. You bring the hot and neutral in, the hot neutral out, and it looks at the arc in line to line or line to neutral. Any question about this? I should bring one of them. Have you guys seen them? Anybody have seen the devices? You installed them, seen them? They've been here for a while. You can test these equipments. Anybody has any of these tester? Ashley, do we have any in our labs? I don't know if Karen has one. I don't think. Arc full circuit interrupter tester right here. Can't remember if we have them or not. You can ground fault protection, arc fault, open neutral test. There's a few places where you test. Do you guys remember the seminar that we went to about the arc flash, and the guy was making fun of these? Anybody remember that? He was saying, well, they don't test our equipment. Of course we don't want them to trip. Anybody remember that? And he was saying to trip. But imagine, put yourself in the shoe of an inspector. I want to make sure that baby works. Plug it in. This is supposed to be arc fault interrupter. I push a button. If it trips, it works. If it doesn't trip, it's wired wrong. So I wish he did put it the way he puts it. He was bragging that it doesn't trip, and we're not going to share our secrets of tripping it with other competent parties. It's a lot of politics, but I can see where the inspector gets upset. I need to be able to verify that arc full circuit interrupter works. So between you and the people who manufacture these measuring tools, put your heads together and find a way of tripping your circuit breaker so it can give me an indication that it's working. Anyway, I thought that was really interesting the way he presented it. Tamper resistant. Tamper resistance, you guys, I showed you the other day, TR tamper resistant receptacles. If we had a few of them, underground, tamper resistant receptacle, weatherproof and tamper resistant, weather resistant receptacle, as you can see here. Everybody knows why weather resistance in damp and wet location, because we're just tired of these pieces of equipment falling in our hands. This is required in every wet and damp location. Take this is a GFCI tamper resistant weatherproof. That will run you $19. Is this 20 amp? Probably $20. Anybody bought one of these? I want to bring to your attention first, it's GFCI. Look at this, at 20 amp, right? Everybody knows the 20 amp because of that slot there. Number two, it's weather resistance and tamper resistant. Can you see that? That's what you're supposed to install outdoor. Tamper resistant, weather resistance, GFCI. Now there's a shortcut for that. I don't need a GFCI if I feed it from a GFCI. So you cut the GFCI on it, out of it. So it runs you $20 on that. Any questions about this? Any question? So that's a nice combo. We talked about, guys, replacing the grounding receptacle with non-grounding receptacles. If you have a grounding system, if your system is grounding, and I will replace, you're not electrician, so I really don't spend too much, but that's FYI. You can, for a grounding system, you can use any one of these. Who cares? Because we have a ground. Now take this. You go to an up and two building. You go to an up and two building, and here's your option. To replace, there is no ground here. So to replace it, I can use non-ground, no problem, Chad. It's just non-ground. I can use GFCI, but I have to say no equipment grounding conductor, or I can feed this one from a GFCI. They allow you to feed this from a GFCI, and you have to write then no equipment grounding conductor and GFCI protected. See, either I put a GFCI or by itself, or I put a GFCI and feed another one, but I have to pull only the hots, no ground between them because there's no ground. And I have to put no equipment grounding conductor and GFCI protected for this. This you have to put no equipment grounding conductor. Do I have to put GFCI protected? No, because it is a GFCI. So anyway, it comes very handy if you're a project manager doing apartments, remodeling, and so forth, to know these labels. Or if you're going to be a wannabe electricians, which a lot of you guys are. So that's what they don't want you guys to bring, that ground. If you bring a ground here, it indicates that if I open this box, I think I have mistakenly think there is a ground, when in reality there is no ground. You can, okay, another option is grab the ground here and tie it to any accessible grounding object in the area. I've seen it done where you can use this and you can take it all the way out, just one receptacle, because right in here, here's my hot, here's my neutral. Take the ground, tie it here, because there's no ground. Ground is gone here, no ground. Take it all the way to accessible grounding electrode, accessible point on the grounding electrode, an equipment grounding terminal bar, a grounded service conductor within the service entrance equipment. So basically, I don't know where you do find that, but this you might, an accessible point on the grounding electrode system. So I find my pipe here, and it's grounded. My pipe is grounded, so I can't grab my neutral from here, tie it to my pipe here. That's an accessible point in the grounding system. That's easy. Anyway, I don't like to emphasize it too much, but if you're doing wiring, if I'm teaching you guys to how to wire, that's a big deal. That's tricks of the trade, how to go around. What I did when I did wiring, the best way, honestly, to do it is GFCI, because remember, you're in a house and you're going to, where are you going to take this wire physically, mechanically? How are you going to push that wire all over to find that? That makes sense if you're in the basement. And if you're in the basement, you can pull a branch circuit anyway. So the best application is put GFCI and put right underneath it, no equipment on a conductor. We installed a few of these.
Where do you write that?
Huh?
Where do you, literally, where do you put the label?
They put right under the anywhere on the cover. I usually put it. Where's the? I thought there's a circuit breaker name. Here, you can put them anywhere in this area here. It's a fine little label, or here. The label comes with the GFCI. I'm sure if you guys have seen it. Okay, moving on. Ashley, if you're in a construction and you don't have GFCI protection in the panel, the temporary service, that's what you should have. This power strip that gives you 15 amp. We'll talk about this as we go to the industrial guys. You have to have a 15 amp, 20 amp, 30 amp, 120 and 240 receptacles have to be GFCI protected on a construction site. So something similar to this, or it has to come from the panel itself. There's a couple of applications where you can use them, or you can put all this equipment GFCI right into the meter area. The last thing I'm going to talk about, guys, is surge protective devices. And I told you about here's the system. Do you see that little nasty pulse that came? It will take that pulse. Look at that. See, to take that pulse and press, my friend, and take it all the way right here and bring it directly to. Usually, this is actually grounded here. It will take you directly to Mother Earth. Directly to Mother Earth. Shunts it. So that's basically what they're supposed to do. How do they do it? They make the phase a device very, very close, very small gap, air gap between them. And if the voltage is very high, it jumps. By the way, do you know that, guys? If you keep increasing the voltage, it can jump the gap of an air. You see them in a transmission line. If you get closer, the closer you get to a transmission line, within a couple of inches, you can see that an arc will jump from the transmission line to you and electrocute you. Because there's at certain time, if you get a grounded object closer to a transmission line, if you get closer within inches, depending on the voltage, it will ionize. The term is ionize the air and turn the air into a conductive object and conduct the current to an arc directly to the grounded object and to Mother Earth. So I have a book, not to change subject, but about medium voltage. And it tells you, interesting, the author say, you can make any insulation conductive. Any insulation, you can make it a conductor by pumping into it higher and higher voltage. So put 100,000 volt across a piece of rubber at a certain temperature and so forth. You can make it a conductor. Not a best conductor, but you make it conduct power. So here is the transient voltage protection devices. Anybody installed any of these? Not code, requirement. Where would you install things like this? Plasma TVs, all these sensitive electronic equipment, or electronic equipment in general. Plasma TVs, laptops, you name it. Almost everything has a computer equipment in it now, a chip or something. Or you can, if you're cheap like Chad and you don't want to install a receptacle, you can have a power strip like this. Or if you are willing to do like my friend Nick, you can actually protect it right in here. Full surge protection, suppression right at the panel. And Phil, my friend, that's what we're going to be doing when we go commercial. We're going to protect it right at the panel when we go commercial. Okay, we talk about that. Okay, the last thing, guys, I want you to help me wire this. Let's wire this together. I have two multi-wire branch circuits. This is 12, 3. Are you with me? AWG. 220 amp. 14, 3. This is also. So a 20 amp circuit breaker, we're going to wire. This is a kitchen, typical. You guys are going to do this in the kitchen. And we're going to wire this one. We need two small appliances circuits in the kitchen going through the countertop. Both of them. So how are we going to wire it? grab the black here and tie it to the black. Anybody has issue with that? Black the red from here and tie it to the line side, the red. Right? Okay, the second one, I'm going to use the green here as my neutral. Grab my neutral, tie my neutral from this side to this neutral, and grab the same neutral and take it all the way and tie it to the second end. So now I energized my, granted, is this the load side or the line side? It doesn't say, so I'm going to assume, yeah, I'm going to say this is the line side. Yeah, let's assume it's the line side. I grabbed the power, the shared neutral. Can you guys see how the shared neutral? And I brought my phase. So this one is in circuit 1, this one is circuit 2, and it's a multi-wire branch circuit. So this has to be a multi-wire branch circuit tied together. Questions about that? Now, and after that, I can go into my neutral. Here's my neutral here, and grab it to the neutral side, no problem. And my hot, I use my hot here and grab it to this side. From here, I will grab my hot and go all the way to here, and my neutral all the way to here. And which color? I'm going to use blue as my ground. And my ground, guys, all the ground have to be tied together. So here's my ground, tied to this ground, and bring it all the way here to the ground terminal. And from here, you're going to come to the ground, out of here to the ground. See, the ground is my blue. Ground. I just use the ground for blue. This is neutral, and the rest are hots. This is typical multi-wire branch circuit small appliances in the kitchen that go through the countertop. Typical. I installed it myself many times. Cheap, easy. Instead of 2 cables, now we have 1 cable, 12-3. Tie them together at the surface and bring it. And downstream, guys, you can keep pulling from here. Oops. You can keep pulling from here and from here as many as you want, right? You keep pulling from here. Well, not as many as you want, as many as the circuit can handle. Any question about that? Any question about that? I think that was part of the homework, wasn't it?
Yeah.
So here's one done for you. Yeah. Any question for Chad, my friends? Okay, let me just do me a favor. The last thing I want you guys to do is grab your code book, please, and just do me a single favor and go to to Article 406. 406 that talks about receptacles. 406. 406. If you guys look at 406, a few things code changes in 406. If you look at 406.4 D, replacement, D4. So it's 406.4 D4. It says arc fault circuit interrupter protection. If you are in 2011 fail, if you replace a location, if you replace a receptacle in an area that need arc fault circuit interrupter, you have to replace it with an arc fault circuit interrupter receptacle. But if you guys read right through it, it's yeah, they don't, because they don't exist. If you go the upper right corner, it says this requirement becomes effective January 1st, 2014, a year from now. So if you want to change a receptacle in your bedroom right now, no problem. But you change it effective January 1st, 2014, you have to change it. Okay, tamper resistance, the one right underneath it. Number 3, tamper resistance. If you change a receptacle in an area that need a tamper resistance effective now, you have to change it with a tamper resistant receptacle. Weatherproof, right underneath it. If you change, that's changing in 2011. If you change a receptacle in an area that need weatherproof, all the receptacles in damp and wet location, that receptacle that you change, not you install, change, replacement, maintenance, have to be weatherproof. Very important. That changes in 2011. It's good for you as a project manager if you're doing remodeling and so forth. The last thing I want you guys, I want you please to go to 406.9 A and B. 406.9 A and B. Everybody's there? 406.9 A and B. A talks about damp location. B talks about wet location. This is Tau, my friend, this is where it tells you in damp and wet location you need weatherproof receptacle. Receptacles listed weather resistance. Weather resistant, not proof. Weather resistant receptacle type. If you read through A and B, it will tell you in any location that wet or damp, you need a weather resistant receptacle installed. If it's 15 amp, 20 amp, 120, non-lockable. The lockable are that one. See these round ones? Where the top, these are, they don't need to be listed. The one that you twist. Everything else here, the plug-in, you need to lock in. B, guys, it says in a wet location, also you need in-use cover. Everybody knows the in-use cover? In wet location, you need an in-use cover, so when you plug in your outlet, your outlet will be covered from the elements as it's engaged in the circuit. So please highlight these 2 locations. And here's my friend, Mr.
I have a CD for you with all Gear 4 stuff on it.
Okay.
All dropped off.
I'm almost done. Are you going to be in the office?
I think I will be.
Okay. I'll swing by. Thanks. So these are changes in 2011 that you guys should be aware of that. Any question, guys? Any question? Do you guys, as long as we're on it, I want you to go to 406.12, please. 406.12. When I take you there, if I were you guys and I'm not familiar with the code, highlight these. These are major things. So 406.12, tamper resistance. All the receptacles have to be tamper resistance in residential. There's exception. Remember we talked about the exceptions, guys? Thank you, Chris. You told me about the exception. If a receptacle for my plasma TV is at 7 feet off the finished floor, that doesn't be tamper resistance. If my son is going to climb 7 feet to reach that receptacle and plug in paper clip right into the hot, he's got a problem. A discipline problem, and I'm not a good dad. I'm being recorded here, so I have to be careful what I say. Discipline problem, it's my problem. Okay? It's not my wife's problem. So if it's higher than 5'5", guys, 5.5 or 5 feet 6 inches, then you have to no problem. The second thing, guys, receptacle as part of luminaires. So Tao, my friend, do you guys see them in residential? They have that light that has a receptacle in it. No problem. No tamper. Receptacles, single located, 2 located with dedicated. If you have receptacle in a dedicated space, what comes to my mind, guys, is the refrigerator. You have a refrigerator receptacle, and you push the fridge. Dedicated space, right? I mean, a kid is going to move the fridge. That receptacle doesn't have to be tamper resistant. All other receptacles have to be. And also, if you're refusing, Chris, you go to your mother-in-law and you're replacing her receptacles in her house that doesn't have a ground in it. Supposedly, they don't make a tamper-resistant non-grounding receptacle. So you have to change it with you don't have to put a tamper resistant receptacle. I disagree with this one because Tao, my friend, you know what you can do? You can change it with what? A GFCI tamper resistant, and that's okay. But and the last thing I want to mention right underneath it, guys, 406.13, 406.14, fail they expand the use of tamper resistance. Some of you look at me and say, Chad, well, I work at Hunt Electric and they don't do residential. Take this. If you go do guest rooms, hotels, motels, casinos that has hotels, motels on them, all the places, guest rooms and guest suites have to be tamper resistant now. Now we're getting into more commercial. If you get into also child care facilities, if you get into a child care facility, guys, it has to be tamper resistant. And they define later on, they define the child care facilities as four kids full-time or more. So that, and 7 years or less. So all your grade schools receptacles, right? So you have more than 4 kids, and in grade school and in kindergarten, those are 7 or less, right? So that will make schools tamper resistant receptacles. So anyway, just be aware of that. 2011. Any question, my friends? Any question? This is probably the last time you will hear Chad talking in details about ground fault and arc fault, so I spent some good time about it, guys. Later on, we're going to start taking part of that building that we have and analyze it. So we'll say if it's a kitchen, you're going to hear, oh, a kitchen, yeah, it's ground fault circuit interrupter. So, any question, guys? Any question about that? Okay. I'm going to stop right here.